Hello reviewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about Chinese Geely Cross says 48% efficiency in a combustion engine. So let's dive deep into it because that's a big number. So what's the claim? Claim is this puppy, IHEV hybrid drivetrain. Be mindful, companies generally make few drivetrains and then they put a different chassis on it. So this drivetrain has this engine. This engine is record-breaking 48.41% efficient. If that number is true, that's huge. And be mindful, this is not mild jump. We had the mild jump era, let's say from 2000 to 2015, where it's like, okay, I am 30% efficient, I am 31% efficient, I am 32% efficient. No, they are directly going from right now, what you can buy best of the best in the market from 39 to 41. That 3% is the bandwidth that you're going to get right now. So in a good case, you will get 41%. In a decent case, you're going to get 39%. So jumping from that to almost 8% complete jump, that's magnificent if true. So what's the alternative? Alternative right now, Toyota is in the island of quite high efficiency. They hit 40% as in like road vehicle, like you can buy it, test it, and it will give you that. That means it is giving you 1 unit of electricity for 201 gram of fuel. Be mindful, engine measurement has to be done this way. This percent number means nothing. So, and again, engine different horsepower and all that. You can have the same chassis, same drivetrain on different chassis. Like they have the same engine on SUV and sedan. Both have different tonnage, different wind resistance. So even if you make the weight same, wind resistance would be different. So one would consume more fuel. So that's why to remove all this hassle and know how efficient engine is, engine to engine comparison, we use grams per kilowatt hour, as in you measure the engine, the power output per RPM, per torque loading, and you plot it out, how much fuel consumption is there, and the lowest number is the highest point that you can hit, max thermal efficiency. So 40% Toyota has achieved, which is 201. That's like damn good. Be mindful, in the early days, as in like as early as 2000, you would be lucky if you were getting 1 unit of electricity for 300 grams of fuel. Average car, which is like not maintained, not fine-tuned, not like pinnacle of precision, that is going to give you 250 to 220, I would say. That's if you're getting lower than that, is like either tune the engine or get it serviced or something else. And which engine I'm talking about? I'm talking about 2L, 2-liter variant, M20A FXS. This engine, again, I'll talk why exactly I'm talking about this engine. But again, this is a well-respected, sold engine. Like they have sold enough of it that USA took it seriously. And this is not a mild jump. This is a quantum leap. Like we have almost reached a point where every Tom, Dick and Harry says engine technology-wise, unless you fundamentally change something, we reach the plateau. Like it's not going to be that much better. It's like, it's your smartphone. Every next smartphone won't be like, whoa, like we crossed that threshold long ago where it's like, oh, 2 megapixel camera, 12 megapixel camera. Once you cross 24 is like, meh. So we have crossed that. Like this is the plateau. So how the heck they are reaching this? Now, there is another vector. Reaching this efficiency, it's not that difficult. It's just that reaching that efficiency while making a mass producible car. You can have magical coatings. You can have magical energy recovery systems. You will cross this efficiency like F1 does. But you can't mass produce it. Like Toyota, I can guarantee you Toyota engineers like, yeah, give me infinite money. I'm going to give you an engine that maybe goes as low as, let's say, 198 or maybe 140. Again, 140 is too optimistic, but that's the whole essence. You can go very low. So if on a road car, like you can just buy it, not a flagship car, you can buy it, not a luxury car, that would be a magnificent deal. And car claim is 45 kilometer per liter. That's huge. Like in American guys, 105 miles per gallon. That's bonkers. So claims are magnificent. Let that be very clear. Whether the engine is or not, I do not know, but the claims are. Whew. So how the heck they are achieving it? Well, they have the same engine like you and I, but they have deep Miller cycle. Be mindful, engines are designed for different vectors. Some engines are designed to have operating range. Basically, if you are making JVC bulldozer, you want that engine to like tank anything. Oh, you want bonkers torque loading on super duper low RPM? I got this. Oh, you want to go all out, super duper high torque at super duper high RPM? I got this. That's a different engine philosophy. When you're making an engine for specifically one thing, efficient, basically burn as little fuel as possible, Miller cycle makes more sense. For example, when you are doing the exhaust stroke, after that you take breathing stroke. It's like, and then you compress. It's like, now that compression stroke is a parasitic stroke, meaning it consumes energy. It's not producing energy, it's consuming energy. Basically, if there was 100 watts of power in your shaft, it will consume almost all 100. So it's a heavy thing, and that's why starter motor requires that kind of torque. So compression burns too much of what you call energy. What if your compression stroke length was different compared to your power stroke? Power stroke, you want like all the power. Give me all the power, all the gas expansion. I want to milk as much as possible. That's good. That's great. It's just that if you have super duper long stroke that gives you super duper amazing power stroke extraction, it backfires during the compression stroke. So it's like, how can you offset them? Now, there were back in the days, people tried auto cycle, if I'm not mistaken, like different linkages and all that. And somebody's like, hey, just switch the timing of the goddamn valve. So the idea is, normal engine is like, top dead center, your pistons are closed, bottom dead center, exhaust valves are closed. But what if, intake starts to close the moment you start to travel up. But how far? Basically, starts to move up, it closes. That's very high compression, great for power, not great for mileage. What if you let it stay open? You're like, hey, okay, let the piston travel up. Now you close it. So you basically let the compression out, almost like a jake brake. You let it out and then you compress it. So you fundamentally changing how much compression stroke is there. That's why the deep word simply means piston is almost reaching full top dead center when they close the intake. Can you do that in normal cars? Yes. It's just that they are time. Again, you can't go and tune it. We have very well valve timing. It can be done nowadays. Because again, the very thing that makes it efficient also makes it very weak. As in, like, you can't like, I'm gonna floor it and it's gonna go wing, wing, wing. It's not like that. It's a very laggy engine if you drive it. So great for mileage, horrible for power band. So deep Miller cycle gives you very good breathing engines. Like, it breathes and does not waste energy in compression. It gives full stroke extraction. So it's very good. Now, how do you power that puppy? Because there is a problem. If you do this deep Miller cycle, you don't have time. You can't use port injector of fuel because, well, it will yeet out of there. You will literally throw away petrol from your intakes manifold. So what to do? You have to use in-cylinder fuel injector. Okay, cool, awesome. How? Well, you have reduced the time frame, right? When the valve closes, only then you want to inject fuel, so your time frame is slower. So use high pressure. Now, 500 bars for a petrol direct injector, that's bonkersly high. Now you're like, wait a minute, isn't that basic bitch pressure for diesel? Yes, diesels had this from like 1980s. So why this is a big deal? Here's the deal. Diesel is a lubricant. So if you have a diesel pump that is creating that pressure, pumps loves that. Diesel is lubricating it. It's like they do not have to fight. There is no mess. It just works. And again, diesel itself is taking care of everything. When you are talking about petroleum or gasoline, that puppy is a spirit, aka that puppy is a solvent. It will dissolve your metal. It will, especially under high pressure, it literally micro-welds the stuff. Basically, your pump will be destroyed. That's why it's bonkers that somehow they had the material engineering or coating that allowed them to hit 500 bars on gasoline. That's like, damn. And you're telling your needle is not evaporating. That's like, damn. So again, 500 bar, not a big deal if you're coming from diesel. 500 bar for a solvent, aka petrol, damn. So that's how you're making sure in the small amount of time that you have, you can still squirt out your fuel and mix it well enough. On top of that, they make sure the cylinder head or like basically valve head, engine head, it's cooled as much as possible. Basically, most of the coolant is flowing there. I'm like, okay, that's normal. Not really. Most car generally tries to cool the block as effectively as possible. They are trying to cool differentially, aka the head cools down as much as possible while the cylinder wall is getting choked flow. Like, okay, why? Well, the idea is when you are going bonkers high compression, you have a arch enemy of gasoline engine in terms of efficiency. You start to have high compression ratio. Great, amazing. You're like, it's great. It's just that it detonates. It does not go whoosh, it goes kaboom. So what we call knock. And again, your modern car literally has a sensor that detects knock. And you're like, wait a minute, why? Well, they design your engine to push to the knock limit. But again, if you are designing a system that is touching 14 or even 13, it's too close. Meaning fuel variants can literally cause your engine to explode. So they're like, okay, we're gonna control the valve system. So if it detects knock, it starts to like, whoa, let the pressure relieve itself. So this puppy is hitting 15.5. That's high. That's high. Like, damn, that's high. That's bonkersly high. That's like the highest I've seen is Nissan, that is like 14. 15.5 is like, damn, that's like long stroke engine. So they're almost reaching a point where they might as well become diesel. So they're making sure the piston head is cooled. And again, to make sure that it's cooled, they have a differential water flow. So water flow on top keeps it cool. A water flow around the cylinder wall keeps it warm. Why warm? Well, friction. Friction is another energy hungry device. What if the oil that is there is far more warmer rather than cooler? Voila, you're gonna get a low friction loss. Again, that's the issue. Once you are trying to optimize beyond 30% efficiency, you have to remove all the hassle like, oh, friction is wasting my energy. Okay, we're gonna make the oil warmer so that friction goes down. We're gonna make the head cooler so we can withstand much higher compression without going knock kaboom. And to make sure all of these things happen at controllable speed, 500 bars of solvent pressure. So far, all of these things are like, other than fuel pump, because be mindful, doing this 500 bar, that itself may not be that big of a deal, especially for people who know how coatings work. It's just that doing that without consuming too much energy. Okay. Diesel systems have enough surplus power. They're like, bro, we don't care. Bosch has like 3000 common rail injector is like 3000 bar. I'm like, what the hell? It's like, it does not care. Gasoline, it will care if your basically fuel pump is consuming so much power. So somehow they have a fuel pump that is efficient and somehow able to run at that sort of pressure. I want to know that. Other things, like, I don't care. Give me that. Another thing is coating. To achieve this sort of coating, they have thermal barrier coating on the piston head. Because again, the idea is you don't want heat, you want expansion. Expansion and heat are coupled. So basically you have a coating that we use in jet engine, turbine blade, thermal barrier coating. You have a coating there, so it goes kaboom. Heat starts to try to choke away. It's like, nope. Ceramic coating is like, nope, go back. So it goes back, the gas does not cool down enough, and voila, now you have more extraction pressure. It's like, woof. It's like, woof. Heat-wise, heat soak is not happening on the piston. So your piston runs cooler and you get more useful work. But again, that coating is expensive. And then, how the heck you're making sure the petrol is not dissolving everything at this sort of pressure? Well, diamond-like carbon, DLC coating. Literally, that's how the pin needles are made. So they can handle petrol at that sort of pressure without evaporating. And then they have physical vapor deposition on other things to make sure that friction is very low. That's why I said, like, having this sort of thing, I'm pretty sure F1 has this sort of things. It's just that it's not cheap. How the heck they're taking that part? It's like, no, we can mass produce it at cheap. That's the hard part. And here's the deal. You did this. Okay, great. Every Tom, Dick and Harry can do that if you have money. Assume you have money. What next? What the problem is, if you make an engine like this, where it's like, it's breathing in, it's like, it's compressing, all of that, it will still have the sweet spot problem, meaning there is only one RPM, only one torque loading where it will give you that mileage. That's why they say max thermal efficiency, not default efficiency. So how do you stay there? Again, if you know anything about engine, only way to do that is in hybrid. And the only way to make sure that engine stays there, AI has to be maintaining it. And yes, I know tech connection talked about like, oh, if you have an engine directly connected to it, that's not how it works. You do not understand engine. The guy knows air conditioning, does not know engines. Again, normal. Unless you know BSFC, it will sound off. Why you do not want to directly connect it? So these are the technologies that they are implementing. So how does it compare? Now, this is the critical part. I would urge you, if you want to understand engines, go into US site, go specifically to Environmental Protection Agency. Every few years, they take out an engine that has been sold a lot in the market. That's the requirement. It must be sold enough that it to matter. They take it out and then they test it. They go all in. And this is their own money. This is not like Toyota pays them. It's their own money. They buy it, they go all in, and all the data is available. So this chart is from Toyota engine. I talked about in the beginning, 2-liter engine. This is the engine we are talking about. And all the data is free. Now here's the Toyota picked in 2019. This is when the testing was done. And you can see this has this island, 220. And that's the efficient part. There is a sweet spot here, but 220, your engine sweet spot is 220, and this is its average spot at almost 3,800 RPM, this can maintain that, and almost lowest RPM it would be 1,800 RPM. So from 1,800 to 3,800, this has 220, and in torque range, you're gonna go around, give or take, 180 Newton meter of torque to lowest is 120. That's a big island. Basically, your car will give you mileage. Has been the main engineering in recent years. It's like, how do we expand this island? Again, no matter which engine you make, this island would be there. Like how sharp the peak is, how shallow it is, that's the different thing, but it will be there. Like, and this is the reason why empty trucks are so bad for environment. You would think, oh, what if I reduce the torque loading on the wheel? Again, it's an empty truck. Yeah, it will burn more fuel. You're like, okay, what if I'm consuming less than 50 Newton meter of torque? Yeah, this puppy will burn 300 grams of fuel per unit of energy. You're literally throwing fuel away at that point in time. And same goes if you overload it. But again, that part I think people inherently know. It's just that this is the odd part. Low RPM, basically if you start to go below 1000 RPM, engine just throws away fuel. It's just like, no. So you always want your engine to hear. That's why hybrid has to be there. No matter what you do, you can't keep your engine here. So Toyota can give you 220 as a good sweet spot where your gearbox should be able to maintain it. And at peak point, you can reach 206. That's their Mount Everest. And Geely engineers are claiming they have not shared BSFC data. That's big sus. Any engine company that comes to you and it's like, we have efficient engine, great, bullshit. Where is your BSFC chart? This chart, ideally great. If they do not give you this chart, because be mindful, companies do not want to share this information because I do not know why. But like, for example, if you buy Scania engines, they have, again, engines are independently sold. So you can find the chart and BSFC is in only 2 axes. This is a 3-axis diagram. So you have RPM, torque and numbering. To make the graph simple, they have what if the torque is fixed and then different RPM. But again, you will get that. So BSFC number, and even if they do not want to share this map, great. Share the peak BSFC, as in like Toyota flat out tells you like 206 is available. So not having that number is a big sus. Even the companies who are developing a new types of engine, they are sharing that number. So I'm like, Again, that's why I hate the number percentage. Means nothing. Give me number. What is the number? And again, when EPA report, it's thorough, as in like we use tier 2 fuel. What does tier 2 fuel means? Go here, look into this, like whole chemical formulation they have provided. So I'm very thorough, very amazing. This chart is amazing. So what does mathematically it means? Mathematically it means you are talking about 170G. That's magnificent if true. Like I'm working on CV engine. I'm hoping we can touch, basically if my Mark 1 reaches below 200, I'm happy, man. I'm printing money. If it touches 150, great. But again, 170 for a 4-stroke combustion engine, for a petrol engine, that's great. Now here's the marketing stunt they did where they had the car, sedan and driving and all that, 45.1 kilo, that's not real. And like, wait a minute, they drive it. Yeah, they drove it without any acceleration, meaning everything was flattened out. AI was tuned so it will only optimize for mileage. So there is a real world test which we call a WLTC test. In that testing, again, Chinese testing itself, it dropped to 25 km per liter and 59.1 miles per gallon. Now here's that's still good. Now, if you are from India, you'll be like, isn't our average cars gives this sort of mileage? Yes, but they are lighter cars. For example, Alto, very popular Indian car, that's 700 kg. My Espresso, I'm pretty sure is still 700 to 900 kg in that zone. These puppies are heavy, 1.5 tons, above ton. So the closest match we have is Nissan 3rd generation e-Power, this puppy. Again, it's hybrid. Again, they also know this, like your engine must stay here. So they have a battery, basically engine drives a motor generator unit charges the battery drives your vehicle. And yes, that is more efficient because your engine stays here. So they are hitting 22 kilometers per liter and 52 miles per gallon. So that fundamentally is that engine block is hitting higher, what you call BSFC. Again, at that point in time, you're looking at 13% gain, which is good. And again, without hybrid, it could not have been done. It's like, no, no, without hybrid, you cannot do that. So what about the drivetrain? This is the critical part. We want this. All your engines, I'm pretty sure most modern new cars have real-time mileage meter, and you will notice that like sometimes it goes too high. Like in my case, my car's official rating is 28 km per liter. Again, it never gives that. Highest I think I have hit is 22. But one time I was driving it and it's like it dropped like 41. How the heck that happened? But again, if your engine reaches the tip of the mountain, it will be that efficient. All cars have that. Like this is 39.8% efficient. Like this is real world testing, like actually testing, third party testing, not Toyota testing, third party testing. They have achieved that. Basically, if you use it as a generator and you can load the basically, let's say 175 Newton meter of torque at 2900 RPM, you will have a magnificently efficient generator. And what about the losses of generator to battery, battery to motor? Yeah, those can be packaged inside 10%. We have that. That's the one good thing about electric vehicle hype. That technology is not only cheaper now, it's actually very efficient. Meaning, if you are buying a motor driver unit, 90% efficiency is like default. Like any OEM part will be that. 92% efficient, a bit more pricey. 95% efficient, ooh, it's gonna cost money. But again, available. 98% efficient, or 96, I think. Highest is 96. Mercedes used that for one car that was almost hitting like 10 kilometers per unit of electricity. Like, I looked at the price of that power delivery unit, as in like the motor driver. I'm like, yeah, no. So again, you can go through all of this and still have that. And again, you will get the smoothness of the torque of a motor. So fundamentally, from 2015, this is normal for all vehicle. 2015, 35% to 40%, it's like duh. Any car that is below that is either made much earlier than that or it's very cheap. So 35 to 40% efficient, that's there. But again, why your mileage is not? Because this is what happens when you drive a car. If you have a gearbox touching your engine, this is what happens. Again, you're not gonna get mileage. Be happy if your car drives at fuel. So that's the main reason. That's why you have to isolate it. Take the same Toyota engine, put all the hassle that you have to do, you will be shocked like, wait a minute, why the heck my mileage went up? Yes, that's why. On a sub-ton car, basically any car that is below 1 ton, again, I don't think American can understand that a car can be under 1 ton, but a sub-ton car can easily give highway speed and 30 kilometers per liter. That should be doable. And tech is now cheap. And you're like, okay, but I want to save the environment. Great, make it plug-in electric vehicle and fuel will be disappeared. Like 90% of trips will be fuel-less. Once in a while, it would be fueled. So this is the drivetrain technology. Again, let that be very clear. Any Tom, Dick, and Harry says that connect the engine to the wheels, not desirable. Not desirable. It's like you have to hybridize it. Ideally, series hybrid. Some people say, no, you can have parallel hybrid, but it's like looking at the complexity of the gearbox. I'm like, give me this engine and we'll series hybridify it and it will be far, better. It's just that one thing that sales manager cannot hold themselves is like, if you parallelize both of them, basically electric motor and engine, torque figure becomes stupid. Basically, your cheap car can behave like a Ferrari and it will overtake a Ferrari. So that's why like people like a parallel system. It's a very good for marketing. Bad for complexity, but mileage wise, the idea is your electric motor will work 90% of the time and it will act as a sponge. It will absorb. If engine is high producing, it will absorb it. If it's under producing, it will dump it. So this is the drivetrain change again. Happened. Let that be very clear. This is what happens in your engine. That's why you are not getting mileage. And you can't change it because again, gearbox is connected to your engine. So what can we expect in the future? Well, reality is you might find it odd. Why the heck Chinese company and everybody is talking about it? It's like, yeah, the subsidy is running out. And again, there are a lot of good subsidies and a lot of bad subsidies. That's normal. Subsidies India gave in solar. It worked so well that we do not have to worry about energy security anymore, electrical wise. That's great, amazing. And we don't even give subsidy on large solar farms. As in like if you cross 10 kilowatt, which generally do not give you subsidy. People are still planting solar farms. 22 kilo. I'm not talking like solar farm. That's a different deal. I'm talking like rooftop solars. People are putting bonkers unit. Why? It's efficient. It makes money. It not makes money as in like it makes your life better. So people are doing that's a desirable thing. And again, Indian government is also winning because they're getting electricity in the back. Electric is not like that. Not for China, not for USA, not for India, for no one. Basically, take top 10 countries from population, like, start with India, then go to China, then go to USA. You keep going down to number 10. You will find all these 10 countries, depending on their economy, they poured bonkers amount of subsidy in electric and they burnt exponentially larger amount of fuel in this 10-year period. Basically, they are giving subsidy on electricity, nobody is buying it, and they are burning more money to buy fuel. And as fuel prices are going up, that subsidy pressure is piling up, even for China. That's why BYD, which started as an electric-only company, now has hybrid, because there is rumor that China's what we call new energy vehicles, that subsidy is about to close, and it has burned, give or take, like multiple billions of dollars. Like nobody will make electric vehicle if you remove the subsidy. Like nobody. You can't even touch it. And like the bonkers battery that everybody is adding is like, you will understand why Elon Musk needed $1 billion for a charging infrastructure that was already built. Like again, if you look into the subsidy rat hole, it's like, I get it now. I get it why Strait of Hormuz is a big deal today. So fundamentally, the money is running out. And more companies are going hybrid. Like there are more hybrids in sale today than it used to be in the old days. And this is a bridge technology for today. For example, if you want electric vehicle, which I want everybody to drive electric vehicle, but hybrid, why? Here's the 90% of the time, nobody drives more than 100 kilometer. But if you buy a car that can go more than 100 kilometer, it's painful for everybody. It's painful for the environment, it's painful for your wallet, painful for your government wallet, and painful for the mines. For example, in India, new electric vehicles started to come and it had huge battery, 80 unit battery. I'm like, that's too huge for India. Like huge, like it's bigger than Model 3. What the hell? Oh, government had a subsidy. The larger the battery box, the more subsidy they're gonna give. Of course they did that. It's like that battery size, you can literally divide it into 3 and be like, oh, 3 electric cars. You can have 3 electric cars, lighter cars. Electric vehicles are so heavy because of this stupid range desire that I have. It's like stupid batteries. Again, bigger the battery, heavier the tonnage, more basically lower the kilometer per unit. Basically, your battery car is consuming more electricity simply because it has bigger battery. And yes, engines are featherweight. Engines are surprisingly light. Like, you'd be shocked how lightweight modern engines are. Like, whew, lightweight. So idea is, what can we do today? I'm not talking 10,000 years from now, 500 years from now, because everybody's, oh, electric vehicles, like, worldwide, I think it's 200 combustion vehicle, 1 electric vehicle. Yeah, that's a negative loss. We're gonna burn the planet before electric has any effect. That's today. I'm not talking 10,000 years from now. I'm talking today. It is not fast enough. It cannot replace it. And again, people have tried it, forced it. And fuel consumption, I can guarantee you 2030, fuel consumption would be even higher than what it is now. Again, it may be a little bit higher, lot higher, but it will be higher. The only reason it can go down is a war or another pandemic, those sort of X variable, or population collapse is happening much faster than I calculated. But again, my math says by 2030, you're still top 10 countries. Do not give me some tiny village example of some Europe. No, top 10 population wise. That covers for around 4.5 billion people on the planet. So fundamentally, all companies are going into system, and bridge technology that we do today. For example, in my car, most of the time I'm not driving even 20 kilometers. I will use a normal electric vehicle, charge it in my home, chill, no problem. When I do need to travel for court case 400 kilometers, cool, I have a combustion engine. But again, you are polluting. I'm polluting less. I'm polluting very less. So you reduce CO2 in edge cases, you eliminate CO2 in all the cases. So that's today, current technology. And it's much cheaper now, because back in the old days, of course, if you are asked, like, I want a motor generator unit, they're like, yeah, we can build it. Honda built it in 1998, Toyota built it in 1993. So yeah, we had it. It's just that expensive. They started with freaking nickel batteries, man. So technology was there. It's just expensive AF. Now it's cheap. So technology is much cheaper because of that. So now your car can have smaller battery, meaning don't need bonkers amount of subsidy. No fast charging, because again, when you have to travel very long range, you just have a system. You just have you put fuel, forget about it. Again, this is another aspect. Like, a lot of people have no inherent understanding of kilowatt hour and kilowatt are 2 different things. Power and energy is very different. Energy is cheap, power is not. For example, if I want to have solar farm in my rooftop that charges my electric vehicle, that's easy. But I must charge my electric vehicle slowly, because if I'm like, okay, I'm gonna take all the energy and charge it in 5 minutes, yeah, I can't do that. Can't afford to do that. Because again, power will go up. For example, that Chinese system that you are seeing right now, 5-minute charging, 6-minute charging, 0 to 100%. Yeah, that puppy is megawatt class per car. It's almost 1200 kilowatt. That's why they say kilowatt, so people become stupid. It's 1.2 megawatt. Your blocks run on that. Like, few of those, it's a data center level power consumption. I was like, but it's only for 5 minutes. You still have to buy a transformer that can support it. And again, imagine burning that much money. Will you actually, oh, this time the grid prices are high, so yeah, we're not gonna run it. No, of course not. It has to run 24/7. People have to just go and plug it in. Yeah, you will fry your grid. So again, we want normal AC level 1, AC level 2, we good. DC fast charging, slowly in the future. Right now, we are not there yet. So hybrid today can save pollution, save our environment today, and actually make people healthier. So that's why people are still making new engines today in 2026. That includes all the major manufacturers. Because again, once the subsidy reaches a critical point, the only two outcomes will happen. Either A, government will close the subsidy, or B, government will make a cost of living so high that people will stop having kids. That's the only two outcomes of that. So that's the future. I'm happy that somebody is pushing, and again, I'm seeing more and more company going into hybrid. I'm like, I get it. New energy vehicle, taxes, all of those are being eliminated. Again, series hybrid takes care of everything today. Plug-in series hybrid, all problem goes away. Like just give 100-kilometer range, just 100. Like, but I drive 10,000 kilometer, drive on fuel. We are not there yet where we can put a nuclear reactor in your car. Just for today, let us survive today. Tomorrow we'll worry about better things. So this was my presentation on basically this new hype that is going around about the engine. I hope it works, but let's see. Again, I'm big sus if you do not provide BSFC number. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. If you have enjoyed it, click the like button. Subscribe, press the bell icon if you're free, and as always, thanks for watching.